Hi there once again, and welcome to another Expresso mechanics tutorial. And in this one we're going to be building a rig to control a stepper motor, which is what you see on the screen. Now over here in my functions, and these are user data that I've added, I've got a controller up here. Basically we can control the speed, the number of steps, and we can also control the direction in which the motor actually turns. At the moment we've got it in forward, we've got 95 for the speed, and we've got 25 steps. So that will actually turn the motor from here to over here, so a quarter of one turn. So let's just play the animation and see that happen. And there we go. It turns around until it gets to there and then it stops. So if we were to increase this to 50, and let's put it in reverse, go back to the beginning of the animation and play from here, we can see that what's going to happen is that it will now turn through half of one turn because it's a 100 stepper motor. And there you go. So that's how this is working. And of course these things are used in high-end engineering projects such as robots and surgical equipment, that kind of thing, surgical robots. So wherever you sort of need a high degree of precision, that's where you'll find stepper motors. But anyway, that's what we're going to be about in this tutorial. So without further ado, let's see if we can make this happen. We'll start by bringing in a cogwheel, and then we'll make some adjustments to the teeth in the teeth tab here. The type we don't need to touch because it does need to be an involute, and it needs to be 25 for the teeth. The orientation we need to make 7.2 because I want it halfway between two teeth when it's at the top. That's where I want it to start. Now, the root radius we can leave as it is, and the addendum radius too, but we'll adjust the pitch radius, and that needs to be 76, and everything else will adjust accordingly, and that's fine. The next thing we need to work with is the addendum, and that needs to be changed from 20 to 2.6666, so 2.6 recurring. That gives us the perfect shape for our cogwheel. Okay. So moving on from here then, we can drop this into an extrude. So holding down the option key, I can drop that into an extrude and then set the offset to 90. And that's the size that I want my rotor. If you wish, in the caps, you can add some rounding. So we could say 1 centimetre for the rounding. We'll leave it at 3 segments, and that will work perfectly well for us. But you don't have to do this step if you don't want to. Okay, so the rotor is basically there for us. The next thing we need to do is just bring in a sphere, and I'm just going to use this as a marker. So I'll give it a radius of 5 centimeters. So it's a very small sphere, and then move it up to somewhere near the top of the rotor. I'll just switch my view to my right hand view and just zoom in a little bit so that I can make sure I've got my sphere in the right place. And that will do fine. I don't think it needs to be changed. The only thing I will do with the sphere is change the colour, and I'll make it yellow. That'll do nicely. Okay, that's given us our rotor, and now we can think about doing a few other bits and pieces. Obviously we need 4 magnets and they need 4 coils around them. So we'll move on to our magnets next. One thing I'll do before we move on is select everything here, hold down option G, and then rename this null rotor so that we've got everything grouped. Fantastic. Moving on from here with the cogwheel selected, I'll just command drag to copy it because we do need another one. And then the pitch radius we simply need to alter to 94. Okay, great. So we're well on our way. Let's switch to our front view. And we can see what we're doing here. We've got the cogwheel selected, points mode, and we need to hit C to make the cogwheel editable. Fantastic. So we've got that ready to go. Now, I need basically everything from there onwards deleted, and I need everything from on this side from here deleted. All of that's got to go. So let's select our rectangular selection, hold down Shift, select all of the remaining points and hit delete. Fantastic. So we've got it that far. Let's just zoom in a little bit closer so that we can see where we are. The next thing to do, I'm going to select all the points. Let's just select a point, hit Command A to select all. And in our spline here, I'm just going to go to my tangents and hard interpolate them. That's the first thing I'm going to do. What I'm also going to do now is think about losing some of these points because I do not need them all. So the middle ones I can get rid of, because I'm trying to create quite a sort of hard-edged model here. So let's just get rid of those, and we can also get rid of these two. Don't need them. Let's just get rid of those. Fantastic. So now we're starting to get what I'm looking for. We've got a much harder edged model. And we can also get rid of a few more points here. We can get rid of these two, and we can get rid of these two. That's good. That's ready for the next step, which is to select the two endpoints here. And then in my subdivision, and it was just a control click to bring up this menu. Hold down control, bring up the menu. In the subdivide here, I do need 3. It's already set to 3, but if it's 2, just set that to 3 and then hit OK. And now we've got 2 points in there, which is great. That's what we need. So we can select these points and just drag them up until they're level with those 2 points here. And then moving on from here, we can just select these two, bring those up to just above our profile here. Somewhere there will be fine. You can just do this by eye. And then all we've got to do is select the scale tool and scale along the x-axis. And again, I'll do this by eye. You can do it with snapping if you wish to, but I'll just bring that to there, and that will be fine. And that looks great. That's exactly what I want this to look like. The final step is to select all of these top points on our teeth and then move to our scale tool once again. The Z is locked. That's important. So lock the Z. You just want to move these in the X and Y. And then with our axis, we've just got to change the position to object so that we're down at the center. And then we can simply click and drag and we'll get the shape that we want. Something like that, I think, will do nicely. Again, totally by eye. But anyway, that gives us a nice profile and that's looking really good. So the next thing we can do then is select the cog wheel and hold down the option key, and we can drop that into an extrude. It's going in the opposite direction that we need it to. So we can make this -90. And then finally in the caps tab, we can add a centimetre of rounding. And that looks fantastic. That's exactly what we need it to look like. Brilliant. Okay, so that's our first magnet pretty much created. What we'll do before we move on, once again, I'll create, well, in fact, I was going to create a null to put it in. I won't do that until I've done a little bit more work, I don't think. What we'll do is bring on a cylinder. We just bring a cylinder into the scene. And then we'll do some work with this. Now, its orientation is correct because it is in the +y axis, and that's what it needs to be. Its radius needs to be 43 centimetres and its height 40. We can make it just a single height segment for what it is, and we'll leave the rotation segments at 16. Let's just move it into position. So if we bring it up to where we are there, what we can do in our coordinates here, we need to move it 45 along the z-axis so that it's dead in the middle of our magnet. And that looks good. Let's just see where we are if we go into our front view once again, so F4, and we just bring this up to somewhere around there. And in our caps, we'll also put a fillet on it, and I'll make it just 1 centimetre once again, just to keep everything the same. Drop this down until it's just about touching, and that's fine. So that's perfect. So our first magnet is basically complete. And what we'll do, I'll just drop this under the cogwheel so that it doesn't interfere with the extrude. and then we're ready to rock and roll and copy these out. So let's just select that. It's brilliant because this is already in the correct place, and then all we've got to do, holding down the command key, and we'll switch to our rotation tool, holding down the command key, we can click and drag, and then hold down shift, and we can rotate this through 90 degrees. Again, just release the shift, click and drag with the command selected, click on the shift again, just to make sure that we're rotating in 5-degree increments, and we've got 90 degrees there. Repeat the process once again, and we're there. We've got our 4 magnets well and truly started, and we just need to put the coils around them now to finish everything off. But before we do that, let's just arrange them. So we'll drop this one down here, this one here, and finally this one at the bottom. Close them up, and finally we can Option G, group them, and call this magnets. Fantastic. So we've got that part of it ready to go. What we'll also do is just bring them a little bit closer to the rotor. So with our scale tool selected, we can just click and drag, and we can bring these to where they need to be, which is about there. Beautiful. Fantastic. So all we need to do now to complete this build is create the coils, and that will be our next step. I'll bring in a helix. In the plane, we'll set that to XZ for a start. The start radius can be 43, as can the end radius, so both 43 for those. Start angle will make -90, and the end angle 11,790. So there's quite a few coils. The height must be 35. And then the subdivision here, I'm going to make 159, and that will give us something that does resemble a coil of copper wire. To position this correctly, we'll open our top magnet, and we'll just drop the extrude into the cylinder. In the coordinates, we can then zero out the Z and make the Y -17.5, and that places it in the correct place. We can just drop that to the bottom of the object list and close the magnets up. Moving on from here, I need a circle. So I'll bring one of those in, drop it just above the helix, and make its radius 0.5. It's in the correct plane, the XY is correct. The next thing to do is just select a sweep and drop it here. And I'll place both of those in there. And the reason I did that is because the sweep is at the center of the world, and that's where I need it to be, because we're going to copy these. So I'm going to rename this coil 1. And then, as I did before, I can just select my rotation tool, hold down my command key, start to drag. In fact, what I need to do, I've got my axis tool selected, so I need that switched off. If I just hold down my command and drag and then hold shift, I can rotate this into position and then repeat the process. Just get that one in there. And finally, my last coil can be dropped into position there. Fantastic. So we've got all 4 coils and they're ready to go. Just drop these down here. And I'll just do a little bit of renaming. Just take that away. Coil 2. Go down here. Make this coil 3. And this one coil 4. And that's great. They're all ready to go. I can select them all. Option G and call this null coils. And everything is now ready and set up as we need it to be, and that does complete the build. And we can see that it all looks really quite nice and everything is where it needs to be. So I'm satisfied with that, and I think we can move on to the next step, which will be to create a couple of materials. So we'll create 2 of those. Name this one red and this one green, and then we can give them their appropriate colors. Let's see what we've got. So make this one red That'll do nicely. Make this one green. And those are ready. And then what we'll do is simply drag the red onto coil 1 and the others can all be green. So we can command drag these to copy them. Okay, and the reason we're doing this is because obviously I'm using these to illustrate how the machine is working. So what's going to happen is when these are charged, they're going to be red and the teeth will all align. That's exactly how a stepper motor works. So the coils are basically charged in sequence, causing the motor to turn, and it makes all of the rotor's teeth align with the teeth of the magnet. That's what happens in the real world. Okay, so that completes that little step, and now we can move on and think about adding some user data. We'll bring in a null and rename it controller. That's ready to go, and then we can work with our user data. So we'll add user data and start bringing a few things in. We'll add a group and remove it from the user data so that that doesn't display anymore, and we'll drop our data in here. Now the group, we'll rename that functions, and that's taken care of, and our first data will be called speed. It will be a float data type. The interface will be a float slider. The unit a real value. Steps of 1, but we're going to start this time from 2 and go through to 100. You'll see why I'm starting with 2 a little bit later in the tutorial. There is a very good mathematical reason for it, so we'll get to that a little bit later, as I say. We'll also clamp these values as I always do, and that will be okay for that. We'll add some more data, and this will be number of steps. Again, a float data type, a float slider for the interface, a real value for the unit. Steps of 1 is fine again, and on this occasion we'll leave this as it is, 0 to 1000. We might as well leave it there. We'll clamp the values, and that's all ready to go. Finally, we'll control the direction of our motor. So direction, the data type will be an integer. We will want radio buttons, and we'll say 0 semicolon forward, 1 semicolon reverse. And that's perfectly good, and we can just see the example there. That's exactly what we're going to get, which is what we want. Just to finish things off, we'll add some more data, and I'm going to drag this up here, and this will be simply a separator. We'll take away its name and then command click and drag it to here, just to put a little bit of gap between each of our parameters. Right, so if we hit OK, we can see that we've now got it. So we've got a functions tab, and we've got our controls here, or our functions here. Great, so they're all ready to go. And then the next thing we can think about is basically working out our expression. So it's going to be Expresso and Python from here onwards. Before we get started, I just noticed that the rotor's null is not in the centre of the rotor. So what we need to do is just remove everything from there briefly and make sure that we zero this out. And then we can place everything back in there. And now the rotor is where it needs to be, because we're going to be using this as the centre of rotation. Let's bring in a null, give it an Expresso tag, and we've got the window open and we're ready to start work. Now, the first thing that we can bring in will be the controller. And at the output stage, we'll come down to functions. We'll start with speed at the top, number of steps, and finally direction at the bottom. So that's all arranged the way I want it. The next thing to do is bring in the rotor, and at the output stage we'll give this a rotation B port. Moving on from here, I will bring in a degree node because, as many of you will already know, I much prefer working with degrees over radians. I just find it much more intuitive and easy to understand. If you don't want to work with degrees, you can work with radians and just leave these degree nodes out, because I'm going to use another degree node a little bit later. Okay, so that's the next step. Moving on from here, I need 2 math nodes. So I'll bring one of those in. And that one will be a math add, so we can leave that as it is and just command drag to copy and then change the function of the second to subtract. So what we're dealing with here then is the direction. We're actually going to be working out the part of the algorithm that's dealing with the direction. So let's just bring that down here. We can plumb the outputs of the degree node into the input ones of both of our math nodes. And at the output stage of both of those, I'm going to put 3.6 in there because I want my rotor to actually rotate in steps of 3.6 degrees. That's what it needs to do. So that's got that far. Now the next thing is to bring in a logic condition node. So we've got one of those, and this will be controlled by the output of the direction. So we'll plumb that in there. Just move that up a little bit so that we can see what we're doing. And then we can plumb the outputs of our math nodes into the remaining inputs of the condition. And that's that little part of it set up. And if we bring in the rotor once again and give this a rotation B port at the input stage this time, and then command drag to copy to give us our second degree node, and change the function from radians to degrees to degree to radians, plumb these in like this, we'll see that the rotor will actually move. And sure enough, it has. And you can see it's progressed by 3.6 degrees in a forward direction, and now it's lining up with this magnet. Okay, so that's what we need to happen. We'll just unplumb those for the moment and it will step back, set up where it was originally with the first magnet. We will need these, but not quite yet. So we'll just move them to one side for a moment and then come back and start working on the next part of the expression. And we're going to be dealing with the speed. So what we'll do is bring in a range mapper. Just place this somewhere here. We can plumb the speed into the input. So we've got that sorted out to that stage. Now the input lower will be 2 because we were working with values between 2 and 100. So 2 and 100 is the input range. And then what we need to do is say 100 to 2 as the output range. So we're literally going to swap things completely round. And we need to do that because we're working with a modulo. So we'll bring in a time node next. That's the next thing to bring in. As per usual, remove the time port and add a frame port. So we'll delete that time port, add a frame port at the output stage. And then we can bring in the modulo. So we'll tell you what we'll do. We'll just copy this add. So command drag to copy, change the function to modulo. And we can just put a 0 back in there. We don't really need to, but we will. So our input will be the time or the frame port from the time node. And the input number 2 we will take from the range mapper. So that will allow us to control our speed, because obviously we're going to be looking at what's coming out of this port. Now, when we get a 0 out of here, depending on what our controller is, and at the moment it's set to 2, so the rotor is going to move quite slowly. So we can adjust accordingly, and that will all work perfectly well for us. So that's our speed actually worked out. Now the next thing I'm going to do is bring in 2 compare nodes. So I'm going to bring in the first one, place it just about here, and this compare I'm going to use the actual frame output from the time node for, and it will be equal to 0. So this is going to do something when we're at the start of our animation. You'll see what that is in a little while. The second compare, and I'm going to command drag to copy and just place that somewhere here for now. I'm going to take the output of the modulo for this one and plumb it into the input 1, and this compare is going to be equal to 1. Okay, so that's slightly different to the other compare. The next thing to do is copy this condition. So command drag, and we'll copy this to over here. And what we're going to be using here is the output of this compare that's being taken from modulo to switch the condition. Okay, so we'll switch the condition when we've got a 1 coming out of this compare. Or rather, when this compare has been satisfied, there will be a 1 coming out of it anyway when it's been satisfied. But once the modulo hits 1, that's going to trigger the compare. We're going to get a 1 at the output, and we can switch to this input. Okay, so that's fantastic. Now, when we're not switched to this input, we need to be using the output of this degree node. That needs to be going in here. So we're going to hold the rotor in its current rotation when we're not moving it. Okay, so that's fine. The next thing to do is connect this condition to the input of this one. So the second input of this second condition here. So as soon as we're hitting 1, we're actually going to be using what's coming out of here. We're going to rotate just one click basically. That's what we're going to do every time we get a 1 coming out of this compare. So that's fantastic. We've got that far. The next thing we can do, we'll just unplumb this degree node from the rotor. We can plumb this into here because we'll need that next. And then we're okay so far. Now, the next thing that we can do, if we wished, we could probably plumb this into here. And let's see if anything's actually going to happen. So if we play the timeline, we can see that we do actually move 1 click. Now, what are we doing when we go back to 0? Are we actually doing anything? Now, at the moment, we're not, because we still need another condition. So we need to copy this one, plumb it up, take it over here, and this output from this compare needs to be used to switch this condition. So when we're at the beginning of the animation, we want our rotation of our rotor to be 0. We want to take that back to 0. So we can leave for the moment, in fact we can leave completely the input number 2 at 0. And all we then need to do is plumb the output of this degree node into here and plumb the output of this into here, and we can see that's gone back to 0. It's already doing its job. So let's see what happens now when we play. We get 1 rotation and we get that. That's fine. So we would get more rotations. I mean, the reason we're only getting 1 rotation is because our controller, we've got things set up in here quite low. So if we set our speed control to around, let's set it higher, so somewhere around 95, we should find we start to step through. And we do. And if we click reverse and then play again, we go in reverse. So it is working, it's doing what it needs to. We'll just give ourselves 1,000 frames so that we've got something to play with. But so far you can see that this is working. Now you could actually finish the expression here, but there's more that we need to do. Because if you want to control the number of steps and make the motor rotate for X amount of steps and then stop, then we need to do something more. And of course I'm using the animation of basically materials to show us which magnet is being charged at which time, and that's that is an optional extra, but it's well worth showing you how to do it, because the code that I'm going to use to make that happen, and yes, that's where the Python code comes in, the Python code that I'm going to use to do it could be used elsewhere, so I'm going to show you that. So let's move on from here and bring in the all-important Python node. Let's reach for the Python node, so we'll bring that in right away, and we can instantly delete all the ports because we'll start this from scratch. We need all integers, so I need 4 of those at the input stage, so we'll get the 4 integers set up there, and then I need 1 at the output stage. and that's our Python node initialized with its ports. Now we need to rename them. Our first port needs to be renamed frame, and surprisingly enough, we're going to be taking the output of the time node and plumbing it in there. Let's just move down a little bit, give ourselves a bit more space. Our second port will be called trigger. Steps for our third. And finally, direction for our fourth. And our output stage, we can rename that stop. Okay, so all of our ports are set up and named. Now we just need to plumb a few more wires in. So from our modulo here, we can plumb this into the trigger. And down here, number of steps can be taken and plumbed into steps, and direction into direction. Fantastic. So that's our Python node set up at the input stage and ready to go. The output, we'll worry about that later. That's going to be pretty much the last step that we need to worry about. Okay, moving on from here, let's switch to a scripting layout and select our Python node once again and open in editor. And we're ready to start moving on from here. Okay, the first thing I'm going to do is remove this line of code. And then up here, I will say from collections import double-ended queue. So deck as it looks to be, but it's double-ended queue. This is a special kind of list that we're going to use, and it has some functionality that's very important. So we can move on from here and add some more variables to our global line here. So we need indexes, and we also need count, and you'll see what these are going to be used for in a few moments. Now, moving on from here, we can define our first variable. So that will be coils. And coils will equal, and it will be doc dot search object brackets single quotes coils. So we're looking for this null. And if we print our variable, we'll see what happens. So let's execute that. Now at the moment, nothing is happening. And the reason for that is because we need a result node plumbed into, or rather we need the output of our Python node plumbed into a result node. So let's just set that up. We'll plumb that into there. Now at the moment, it won't work because we don't have a value for stop. So what we'll do is define one, stop is equal to 0, and we can execute that. And now we can see that things are working. Let's just clear that. So we've got Cinema 4D base object called coils / null. So it's found this object. So that's all working as it should be. The next variable we need is coil. So coil will equal coils dot, and it will be get children. Open close. So what we're going to do then is bring all of these into a list called coil. And if we print it, we'll just clear this out, we can see that we've got it. So because coils are now, or the children of coils, are now collected into a list, and we've got coil 1, 2, 3, and 4. So that's working perfectly. Now, if we open our materials, we can see that we've got 2 of these in here. Now we need to get these into a list. So we'll define another variable. We'll call it materials. And we'll say materials is equal to, and it will be doc dot get materials. Open close. And if we print those, clear this out, straight away we get C4D material called red, and of course another one called green. So they're now into a variable called materials, or a list actually called materials. Fantastic. So that's all working as it should be, and we've got those initially set up for us. Moving on from here, let's think about where we're going next. Now, At the beginning of the animation, we need to initialize a few things. So we can say if frame is equal to 0, colon. For a start, we can say indexes is equal to, and this is where the double-ended Q comes in. So it will be double-ended Q, open brackets, open square brackets, 0, 1, 2, 3, close square brackets. So these are going to be the indexes of coil. That's what we're looking at here. That's what they're for. So they will allow us to look at the individual elements that are stored within our coil list. We can then say count is equal to open square brackets 0. And this will be a counter. You'll see what we're going to do with that a little bit later. Moving on from here, we need a for loop. So for I in range, and it will be brackets 0, 4. And we're going to sequence through these here. That's what we're going to do next. So let's see where we go from here. For a start, we can say if I is equal to 0. So we've set up a special condition for our first coil. Okay. We can then say first. So this is the variable that we're using to look at these individual tags here. So first is going to be equal to coil brackets I dot get first tag, open close. So when we're looking at our first coil here, we want this tag. That's what we're going to be bringing in. We can then say first dot set material, and it will be brackets materials, open square brackets 0. So in other words, we want to give our coils tag here a red material because it's the first in the queue. Moving on from here, we can say else, and we can copy these two lines, paste them in here, and simply change the 0 to a 1. So if we're looking at anything else within our coils list other than the first element, we want them to be green. That's what we want to set things up with initially at frame 0. And that will do that for us. Or will it? Let's just see if it does. So let's just execute this code and see what happens. Straight away we get a problem with the result, and it's saying that here we are, attribute error. So C4D selection tag, object has no attribute set material. So what's going on there then? Let's see if we can do something to find out. So let's get our print statement from here. Put it in here and say print first. And let's see what first actually is. Just clear that out. Right, let's have a look. So, right, first we're being told is actually, let's just get rid of print materials because we've got that in there still. Just clear that out. Right, here we go. So it says that C4D selection tag object called s/cache proxy tag. Right, so it doesn't think these are material tags, it thinks there's some kind of proxy tag. Well, why is that? That's really bizarre, because surely these are material tags, aren't they? Well, yes, they are, but the problem is our coils are currently procedural objects. So these are being dealt with in a different way for that reason. So what we need to do is actually select all of these, hit C to make them editable, and then we can open the nulls that they reside in, remove them, so that we just get the objects there. And then what we can do is we'll just remove all of these tags. We'll just remove every last one, and we'll take this away. Well, in fact, we'll take these objects away because we don't need them. And then we can reassign the tags. So let's just go into here, give this a red, give all of these green. Okay, that's done that. And now let's see what happens when we execute the code now. So now let's have a look, see what we've got. So at the moment, we've got a problem still because, of course, these are now the first tags. They're Phong tags. So all of these have got to be moved to the front of the tag list there. Let's just get those to the front. And now let's see what we get. Execute. And now we're saying C4D.texture tag called material. So that's different. We've got materials in there now, and that's all good. At line 31, we've still got a problem. It still says that we've got a slight error there. We shouldn't really have, because everything should be fine. It's materials. The reason I've got a problem there is because I put materials I should have put materials 1. Let's just take that back. And now everything in the garden is lovely and it's all working as it should be. But it was just worth showing you that because that confused the life out of me when I saw that. I just thought, well, these are material tags, so surely there's no problem with that. But it's because the objects were not editable. So it was well worth showing you that, because that really would cause confusion. Okay, fantastic. Let's move on from there. So we've initialized everything at frame 0. That's as much as we need to do there, and that's all set up and it's going to work for us. Let's move on to the next step. So we can now say if count brackets 0. So this is where we're using our counter. We can simply say is less than steps. So we're comparing our counter's value to what's coming in at this input from the steps. Okay, so as long as we're less than steps, we can just continue counting basically. So we can then say if trigger, so this is where our trigger input is going to be used. So if trigger is equal to 1, so if that's been triggered, we can then say count bracket 0 plus equals 1. So we can count one value. We can then say if direction is equal to 0, indexes dot rotate brackets -1. Else, and it will be this line we can copy, paste it in here, and we can simply put 1 in there. So this is allowing us to rotate these numbers either one space to the left or one space to the right, and it will take the number at the end and put it at the beginning. And that's why we're looking at the first number, or will be looking at the first number in this list with what follows. Okay, so that's really essential to make that point. And that's where a double-ended queue is fantastic, because it does allow this rotation of the elements within it, unlike a standard list. We can now say, let's have a look, actually what we can do is going to be the same formula as we've got here with just a few differences. So we'll copy this code, we'll paste it in after the else, make sure that our indentation is correct. So again, if I is equal to 0, it will be first is equal to coil, but instead of saying coil brackets I, we need to say indexes brackets, and it will be 0 in there, double close. So we're interested in the first element of indexes, and because these can rotate, they're going to be constantly changing, and that's why we've got to say indexes 0 as opposed to indexes I. And that's fine, that's all set up and working. And then down here we've simply got to do the same and say indexes brackets. This time it will be indexes I, because we want the rest of them, double close. And that's as much as we need to do there, and that's fine. And that will set up our materials as we need them to, as these move around. So that's fine, that's working exactly as we need it to. Now stop is equal to 0. We can just tab this in and place it one indentation in. So we can just place it here literally. And then all we've got to do is say else stop is equal to 1. So once our steps, or rather our count, is greater than or equal to steps, I mean it says as long as it's less than, so once it hits the value of steps, this else will be triggered and stop will generate a 1, and we can use that to stop the rotor turning at that point. So once it's reached the count, the actual maximum steps, then we want it to stop. So that's fine. So we know that we can sort that out and we can get that to work. So let's see where we are from here. Let's just basically move over here. We can make the window a little bit bigger, and we can start thinking about what we're going to do in order to make the rotor stop turning. Well, for a start, we need to bring in another condition, and we need to plumb it in and get it set up and working. So let's see where we're going to go from here. Well, the switch is going to be controlled by the stop, so we can plumb that in there. And then the next step for us is to say that we want to plumb the output of this condition into our first input there, into our input number 2, and then our final input, this time we will take it directly from this rotor null here. We don't need to use the output of this degree node, we just need to bring it from this here. So we can plumb that into there, and then we can select this and plumb it into here. Okay, and that's the setup for the entire expression complete. That's what it looks like when it's finally done. Now let's just see if we've got any problems. We probably will have, because it wouldn't be an Expresso mechanic tutorial if we didn't. But let's see what's happening here. So let's have a look. I've got coil 1. Where is coil 1? Coil 1, coil 2, coil 3, coil 4. Right, coil 1 has somehow managed to rotate itself by 90 degrees. So let's sort that out. Where are we? We need to get a hold of our coil and rotate that back to where it should be. So let's just rotate that back to there. That's fine. So that's okay. That's where that needed to be. Let's have a look. Yeah, it looks as if it's okay. Right, let's see if we get anything when we start running the timeline. Make sure I've got no print statements in there. I don't think I have any more. No, that's okay. So this should clear. So let's see if we get anything here. Well, we're not getting anything at the moment. So we need to have a quick check through and see if there's anything going wrong. Actually, I don't think there's anything wrong. If we select the controller, yeah, at the moment we've got a number of steps set to 0. So let's just make that, I don't know, just go, let's go 16, that'll do. And we'll put it, I think, in forward mode, and let's see what happens, see if we get anything now. Where are we? Speed is 95, so let's just see what happens. Take this back to 0 and play. Ah, and look at that. We're actually getting something. And we've gone 16 steps and we've come to a stop. So that's all working okay. Let's set it to 25 so that we go a quarter of a turn, and set this to reverse. Go back to the beginning and see what we get now. And there we go. And we stop at a quarter of a turn. Fabulous. So that is working. It's all doing what it should be doing. So yeah, that's great. And we're getting the output there from that result. We don't need that anymore. And that's your expression. That's what you need to do in order to create a working stepper motor. And you've got your code there. So yeah, that all works perfectly well. Fantastic. So yep, that's what I wanted to show you in this tutorial. So let's just put a few more steps in there, say, I don't know, 70, and we'll put it in forward mode again and just play again and just let it go. But yeah, that's all working exactly as it should. So that's how you go about doing it. So as always, I really hope you've enjoyed this tutorial and that you've got a few tips that you can apply to some of your own projects, and that it's been well worthwhile doing for you. And if you have enjoyed the video, as always, then please give it a thumbs up. And if you haven't already, please subscribe to the channel, leave a comment, and of course, ring the bell. And wherever you happen to be on social media, then as I always say, please do share this video, because all this good stuff really does help keep the channel moving in the right direction. But anyway, that about brings us to the end of this one. So I'll see you very soon on the next tutorial.